Hi everyone. Today we'll talk about scalars versus vectors. Before we go there, the first thing I want to do is go into learning objectives as per the AP. So as you can see, 1.1A1, what are scalar quantities? Describe them. What are vector quantities? Describe them. Then also we can look at how we can visualize vectors using arrows, which will make our life easy to understand them and also deal with them. Also distance, speed, etc., scalar quantity, while position, displacement, velocity, and vector quantities, and we will see how actually it works in reality. Okay. So suppose we have this car, and basically we want to move from one place to another. So we are going to take this car and basically go around the city. Okay. So so let's say we start driving the car randomly around the streets, right? Going back, stop there for some time, then went back somewhere, and then finally come back here. As a result, we can see that we have probably moved about 5 miles, right? Uh, and it took about 30 minutes, right? We don't care how we move, but we know that all in all we moved about 5 miles, right? This kind of thing is what we call distance traveled, right? And this one is time it took, time taken to complete this travel. So this kind of quantity are what we call scalar quantity, right? We just want to know how big or small it is, right? So 5 miles, 2 miles, 3 miles, 1 miles, how big or small it is, right? So this kind of quantity when we describe is what we call scalar quantity, and the distance traveled is the scalar quantity. Similarly, if you look at the time, right, whether it took 30 minutes, 20 minutes, 10 minutes, or 40 minutes, right? So we are just looking at how big or small it is, that is the magnitude, right? So time is also sort of a scalar quantity. Okay. Now we look at uh, next. Suppose this is our home and this is our school, and I tell you go 5 miles from your home, you'll reach school. So if you try that, basically you can go in any direction 5 miles like this, like this, like this, or like that, right? And it's likely that you are not going to reach school in each and every case unless you run very lucky. So in order to actually help you do that, basically it's better that I describe. First go 3 miles, let's say towards east. I first go 3 miles towards east, and then 2 miles towards north. Okay. So as a result, what has happened? We first went 3 miles towards east, and then 2 miles towards north, and probably that's where the road was. So basically, went 3 miles towards east and 2 miles towards north, and we basically reached the school. Now I can ask how much distance you have traveled. Oh, basically we have traveled 3 plus 2, which is like 5 miles in this case, right? But you can see in reality, the actual distance which you traveled was from here to here, right? From this point to the school. Okay. So not exactly. Let's see, point out there. Okay. And as you can see, this is a Pythagoras theorem. We can apply this distance is going to be much smaller, or mathematics is going to be 3 square plus 2 square. That's going to be 9 plus 4. Okay. Okay. And that will be slightly more than 3 and less than 5 miles, right? This kind of thing, basically, we're here at point A and we end up here at the school at point B, right? Eventually, we got displaced from point A to point B, right, which is 13 miles, right? So this kind of quantity, when we say we got displaced from this point to this point by root 13 mile along this direction, right, which happens to be northeast in this case, right? This kind of displacement when is required is what we call vector quantity, right? So you cannot reach to the school in the first place if I do not tell you that first you go to 3 miles towards east, then you have to go 2 miles towards north, right? So if I just vaguely say that we have to go 3 miles and 2 miles, right? You cannot reach school, right? If I have to tell you that first go 3 miles towards east, or right? Then you go 2 miles towards north. Okay. And then only it is possible for you to reach the school. Let's take another example. Let's say we have this cart here and I want you to move it. Right now, you can move it any way if you like, right? Towards the right, towards the left, forward, backward, whatever way, right? But if I have an objective, I want the cart to be moved right, I have to tell you that move the cart towards right, right? Then I can get my work done, right? So I want the cart to move towards the right, so I have to tell you move the cart towards the right. So you have to come here and basically push the cart towards the right. If I want the cart to be moved towards the left, I have to tell you move the cart towards left. They're going to come and basically pull the cart towards left, right? In such a simple situation where push and pull only in one direction, right, is required, I have to provide this information, this extra information, right? So what we are saying that move the cart 5 meters, right? Move the cart 5 meters and do that towards right. Okay. So I'm providing two information, move the cart by 5 meters and do it towards right, right? So this is what is called the magnitude, and this is what is called direction. Okay. Until unless I provide you with magnitude as well as direction, our objective cannot be met. Right. So this kind of special situation in this describing a physical quantity is what we call vectors. Right. The quantities are more specifically physical quantities because we are dealing with physics, so we are calling it physical quantity, right? Whose complete specification is not possible without providing two information. Right? Which are those two information? Magnitude, which says how much, right, by 5 meters and in which direction, right, towards the right. So for example, right, 5 meters towards the right, 5 meters towards the left, right. So we have to provide these two things, right, magnitude as well as direction. Until unless we do that, basically, it is not completely possible to specify what that quantity is, right? Those kind of quantities are called vector, and vector is nothing but just a Boolean name, right? More specifically, or more formally, we can write vector quantities are what they are, a physical quantity, which have both, has to have both magnitude as well as direction. Okay. Uh, Amazingly, we can represent instead of saying like 1 mile towards the right, 3 miles towards the right, 2 miles towards the right, or 2 miles towards south, etc. We can simply use arrow to display that, right? So if this length is, we are assuming 1 mile, so this will represent 1 mile towards east, right? And this arrow is double the size of this, so this represents 2 miles towards east, right? And the C basically is three the size, so we take 3 miles towards east, right? Instead of writing such a long statement, basically we can simply use arrows to display vectors, basically map vectors, and we'll see how easy and useful it is later in the video. You add them up, subtract them up like that, right? So now this one, let's say this is 2 miles long, right? This is 2 miles south, right? This one, 2 miles north, okay? And this one, 2 miles northwest, okay? So instead of writing this statement, basically we can use simply arrow to describe vector, okay? This kind of quantities which require you to do basically tell how big or small as well as direction of all vectors. Or there are other simple quantities where we don't need that, right? So we don't need a sense of directions. We just say I weigh 60 kgs, right? My mass is 60 kgs, for example, right? So it doesn't have a direction. It doesn't have north, south, or left, right associated with it, right? We can say the temperature today is 100 degree Fahrenheit, right? It doesn't require to tell positive, negative, and things like that, right? Or any direction, north, south, east, west, right? So this kind of thing is what we call vectors, scalars, right? So scalars require only the magnitude to describe, okay? How big or small we just specify along with a simple number, and we can add scalars just like that, right? So we just adding like numbers, okay? So scalars can be treated as numbers, okay? And then we can use whatever mathematics we have learned, addition, subtraction, multiplication, division to do this kind of manipulation on the scalars. But when you want to do mathematical operations like addition, subtraction, etc., on vectors, it is entirely different thing, and that's what we call vector algebra, which we'll take up in the next video, right? What we have learned about vectors specifically, the vectors are something which require you to give two information, right? Simply put, the magnitude, how big or small it is, and in which direction, right? The example is displacement, right? I want that car to be displaced, right, by 5 meters towards right. So I have to say 5 meters towards right, or 5 meters towards north, or whatever, right? We have to provide those two information to completely describe what we are doing, right? In that sense, the force is also a vector. In that sense, displacement is also a vector. We'll see velocity is also a vector. But there are simple physical quantities which only require magnitude to be known, right? So those kind of quantities are called scalars. For example, mass, temperature, etc. are scalar quantity, as well as distance traveled, right? So distance travel is sort of cousin of displacement in the vector, but distance travel is scalar. We can use depending upon what kind of analysis we are doing. Thank you very much for watching, and we look forward for your subscription to the channel.